The Taj Mahal has been defined by a single story. It is the ultimate monument to grief, an emperor's tribute to a lost wife, built to serve as a static, eternal symbol of romance. Looking at this sepia-toned image, the building appears almost ethereal, as if a perfect white dome simply dropped from the heavens to the Yamuna. But the sensation that this building is floating or otherworldly is no accident. The 17th century builders utilized a series of calculated optical illusions to control exactly how the human eye perceives the monument. Beyond the marble poetry lies an engineered machine. It was designed to physically manipulate light, harness the flow of a massive river, and survive on terrain that should have swallowed it centuries ago. Uncovering the 17th century physics required to keep this heavy marble edifice standing reveals a structure far more complex than a simple monument to grief. The engineering of the experience begins at this red sandstone gate. As you walk through the archway toward the tomb, the building appears to shrink and recede into the distance, a forced perspective trick designed to make the final reveal feel massive as you step onto the terrace. Look at the calligraphy framing the main arches. While appearing uniform from the ground, distance naturally compresses objects at the top. To counteract shrinkage, architects calculated a specific distortion, physically expanding the upper letters. This mathematical correction forces the brain to perceive perfectly even text. You can see another correction in the 4 minarets framing the central dome. While they appear perfectly vertical, they are actually built with a distinct outward tilt. If these towers were perfectly straight, the human eye would perceive them as leaning inward. The outward tilt corrects this perspective, but it's also a seismic failsafe. In an earthquake, the towers are engineered to fall away from the center, ensuring the main dome is never crushed. The marble walls and latticed screens shown here serve as the canvas for the building's most famous visual characteristic, its tendency to change color as the day progresses. The builders clad the entire structure in Makrana marble. Sourced from Rajasthan, this specific stone is prized for its high purity and fine crystalline structure, which gives it a semi-translucent quality. Makrana marble refracts and scatters light. Rays penetrate the stone before bouncing out. At dawn, it absorbs short wavelengths for a pink glow. Under midday sun, it reflects brilliant white. By sunset, it captures long wavelengths, turning the building into a golden entity. This wasn't an aesthetic accident. By selecting this specific marble, the architects ensured the building would never have a static presence, turning a heavy tomb into a dynamic participant in the local environment. From the terrace, you can see the primary threat to the building's survival. The Yamuna River sits on a shifting floodplain, soft soil that is notoriously unsuited for supporting a massive marble monument. Engineers sunk deep wells into the mud, capping them with structural timber beams. This wood must remain completely submerged in river water to prevent rotting. Because it stays saturated, it acts as a flexible raft, evenly distributing the marble's massive load while dampening seismic tremors. The structure only survives because it actively uses the river as a structural component. The architects transformed the site's greatest environmental threat into its essential lifeline. The survival of the Taj Mahal depends on a delicate, active collaboration between this architectural geometry and the local environment. That balance is currently breaking. Rapid urbanization and heavy air pollution are dismantling the very environmental conditions that have sustained the building for nearly 4 centuries. This photo of the building covered in bamboo scaffolding highlights its modern vulnerability. As the Yamuna River dries up from climate change, the water table drops, leaving the timber foundation exposed to air, where it risks drying out and crumbling under the weight of the marble. Even the optical illusions are failing. Acid rain and particulate matter from nearby industries coat the surface, dulling the refractive properties of the Makrana marble and killing the building's ability to capture the light. The Taj Mahal stands as a masterclass in 17th century physics. But today, it serves as a warning that even the most perfect architectural illusion will fall if the environment that sustains it is destroyed.